All right, so this was the chapter review. Obviously, this is the big ideas. This is the concept stuff. And then if you look, I'll go like kind of section by section. The vocab questions at the beginning, you won't get a vocab question, just need to understand those, right? Pythagorean Theorem, a squared plus b squared equals c squared. 2 says, what does it mean to solve a right triangle? It means to find all the missing sides, all the missing angles. And then 3 is know the difference between the angle of depression and the angle of elevation so that your word problems make sense. Then came Pythagorean Theorem. So keep in mind again that these will be kept exact on your test. So although you'll have your calculator for this part, you'll need to make sure that they are kept exact. Like number 5 would not be a decimal when you write the answer out if it was something like that. Any questions on those 3? Okay, then came 7-2, which is your converse. Remember that you have to check to make sure that they make a triangle first. If it was something like 6 and 3 and 9, it wouldn't make a triangle. So you want to make sure you check those first. And then all of these were classified: 7 acute, 8 obtuse, 9 right, 10 acute, 11 right, and 12 obtuse. Everybody good on those?
For number 11, since it's square root 2 would be between 1 and 2?
Yeah. Yeah, and you'll like to approximate it, you mean? Mm-hmm. You'll actually have your calculator. That's where the benefit of that will come into play, because you can use it, like you can find out what 3 times the square root of 2 is. Just obviously when you go to square it, you don't want to keep it rounded, but at least it will give you the idea that it's bigger than the rest and that the 3 plus 3 would add up to it. Yep.
Can you do number
11? Sure. Okay, so because I know, like, we just said this, like, root 2, right, is going to be like a 1 point, it's actually like a 1.2, let's just say. If I did 3 times that, I get 3.6, right, which is bigger than these two. So I'm going to put that first, 3 root 2 by itself, and then 3 squared plus 3 squared. I'm going to square the 3, making it 9, square the square root of 2, which is making it just 2, and that's 18. And then 9 plus 9. So this is 18 equals 18, which makes it a right triangle. So with a calculator, you can actually multiply that out to see that that's the biggest one, to make sure that it goes on the outside. You could test that out. But when you go to square it in your equation, you want to make sure you keep it exact, as in 3 root 2.
So you can approximate the number of 3 root 2.
To figure out if it's the biggest. But then when you use it in the equation, you have to use 3 root 2. If you approximate it, it's probably no longer right. So you gotta be really careful. It's like no longer a right triangle. All right, 7-3 was your altitude, segment 1 over altitude, altitude over segment 2, and hypotenuse over leg equals leg over segment of the hypotenuse adjacent to the leg. So 13 was 13.5. You could have also left that as a fraction as long as it's simplified. 14, 6. 15, 2 root 10, 16, root 14, 17, 9, and 18, 16. Again, examples of 16 and 15 where they need to be exact and not a rounded number. Brian?
Can you do 15 and 16?
15 and 16, sure. So 15, the x is on the leg of your triangle, which tells you that it's going to be the hypotenuse over the leg equals the leg over the segment of the hypotenuse adjacent to the leg. So the hypotenuse is of the big triangle, that whole side there, which is 10. It's going to go over the leg, which is what we're looking for, the x, equals the leg, which is x, over the segment of the hypotenuse adjacent to the leg, which is 4. Cross multiply, and I get x squared equals 4 times 10. So I can go through the work of multiplying that out, but I'm just going to end up breaking it down again, so I like to keep it separate. X is going to equal the square root of 4 times 10. 4 being 2 and 2, 10 being 2 and 5. There's 1 pair of 2s that's going to go to the outside, and then the 2 and the 5 that don't have a match are going to stay underneath your radical to give you the 2 root 10. And then 16. This time the x is also on the leg, so same ratio. Hypotenuse, which is this whole thing, would be 7. Over the leg, which is x, equals the leg, which is x, over the segment of the hypotenuse adjacent to the leg, which is 2. Cross multiply, and I get 7 times 2 here. Square root both sides. 7 doesn't break down, neither does 2, so this becomes the square root of 14. Any other questions from this section? Okay, then came 7, 4, which was your 30, 60, 90, 45, 45, 90 triangles. 9 is your 45, 45. It either will show you the 45 or because it's isosceles like this one, you'll know it's 45. And then 20 and 21 are your 30, 60, 90. So 9 was 6 root 2, 19 was 6 root 2, 20 was 7, and 21 was 16 root 3. Brianna. 21? Sure. Okay, so it's a 30, 60, 90 triangle. I know that because of 60. This is 30, which makes this side A. This side would be A root 3, and this side would be 2A. So if A equals 8 root 3, and I want to find X here, I'm going to take the 8 root 3 and plug it in for the 2. I'd get 2 times 8 root 3. And then with square roots, I can multiply the numbers that are outside together, and the root 3 would stay by itself.
Well, let's just say it was 2 root 3, then it would be 16 root 9.
So if it was 2 root 3 times 8 root 3,
Mm-hmm.
yeah, then I'd multiply these two together to get 9, and then root 3 times root 3 would, well, I wrote 19. Yes, thank you. 16, and then root 3 times root 3, which is 3, so you'd get 48.
Mm-hmm.
Any other questions from that section? Brian?
Could you multiply, like if it was root 3 and root 2, could you multiply?
Yeah, so if it's root 3 and root 2, if they're both under the square root, you can multiply them. So let's say it was like 4 root 3 times root 2. Or let's say it was 4 root 3 times 7 root 2. The numbers on the outside of the square root are going to get multiplied together. That'd be 20. The numbers that are inside the square root are going to get multiplied together, and it'd be root 6. 28, not 20, 28. So square roots, as long as they're both square roots, like eventually you're going to get into like cube roots, that kind of stuff. You can't multiply a square root by a cube root, but these you can multiply. Connor?
And I know you find the longest side, but you see like the square root, can you solve for it?
Yeah, so if I wanted to know this side, you mean? I would take that 8 root 3, and then multiply it times the root 3. So I'm plugging 8 root 3 in for that A. So then I'd get 8 times root 3, which becomes 3, and that would be 24. God bless you. Where'd the what come from? If it had asked for the bottom side, so it didn't ask for the bottom side. But if it had asked for the bottom side, so let me clear off this extra stuff because this is not part of my original problem.
So you have like square root 3 and then square root 3 and multiply into just 3?
It's just 3, yeah, because it would be square root 9, and square root 9 goes back to 3.
Oh,
Any root times itself is just what's underneath the root.
So you're going to multiply.
Okay, then came tangent. So these, we knew to use tangent, but remember they're all going to get kind of looped in together. It's not going to say use tangent. It's not going to say use sine. You've got to know that SOHCAHTOA. So you've got to know that opposite and adjacent are going to be tangent. Opposite hypotenuse are going to be sine, and adjacent and hypotenuse are going to be cosine. So 22 gave you a little diagram. I would say that this is kind of on level with what you could expect as far as a word problem goes. It's a word problem, but it also has the diagram there to help you out. Angle between the bottom of the fence and the top of the tree is 75. The tree is 4 feet from the fence. That's your bottom distance. How tall is the tree? That's your x. So I'm looking for the side opposite. This would have been set up as the tangent of 75 equals x over 4. When the number's in the bottom, we just multiply. And from there, you'd get approximately 15 feet. It said to round to the nearest foot, so we round to the nearest whole number. Then it says how tall is the tree if the angle is 55. So if instead of this being 75, we change this to 55, everything else stays the same. It'd be the tangent of 55 equals x over 4, and then we'd multiply both sides by 4. And we'd get approximately 5.7 feet. Mateo?
When the number's on top, you just bring it over, right?
Correct. So if it had said, let's say we're doing 26, right? This would be the tangent of 38 would equal 10 over x. When the number's in the top, we take that number and divide it by the tangent. So in the calculator, I would do 10 divided by the tangent of 38. And you'd get that 12.8. So numbers in the bottom, you multiply by that number. Numbers in the top, you take that top and divide it by the tangent from the other side. If you're unsure, put that tangent over 1, cross, multiply, divide. It's the same thing. Any other questions from the tangent part?
So it doesn't tell you to round
It will tell you.
Wait, for 23,
Yeah.
So it'll in all the word prompt it'll tell us where to round.
Yep. Everything that wants you to round something says round to the nearest tenth, round to 2 decimal, round to the nearest foot, something like that. If it doesn't say it, you're keeping it exact.
For 23, instead of saying like negative 5.6.
Oh, that's just a squiggle. It means approximately. It's not a negative. It's a little squiggle. It just means approximately 5.7. So because it didn't tell you what to round to, you could have put a lot of answers there. Test is going to tell you what to round to.
I'm confused on when you just like divide it or like when you actually put like the cosine, sin, or tangent.
So if it said to find the ratio of tangent of angle A, let's say, then if I had a triangle, like if this is A, B, C, it could say find the, and this is what 6, 8, 10. We know that works, right? Find the tangent of angle A as a simplified fraction. Then I know I would put 6 over 8 and I would reduce it to 3 over 4. If it said find the tangent of angle A, round to nearest tenth, then I would do 3 over 4, and then I put that in the calculator, 0.75, which would be 0.8. So the directions will explicitly state what it wants. You just have to read the directions every time. You guys sometimes get chugging along and you skip directions. You got to make sure you're reading them every single question. And then the other time you would use it is if you didn't have a side. So let's say I didn't have this side. This was an X. But I had this angle. I don't know. Then I would use the tangent of 30 to find that side length. Does that make sense? Okay. All right, sine and cosine ratios. So now we're doing sine and cosine. This is again, so see the directions there? It said find sine of x and cosine of x. Write each answer as a fraction and as a decimal. So the fraction would be 3/5, the decimal would be 0.6, and it says round to 4 decimal places if necessary. So the ones like 28 and 29 that continued to go on past the nearest tenth, you would round those numbers to 4 decimal places. So again, watch for your directions. Then 7 was where we used sine, cosine, and tangent to solve the entire triangle. Solve meaning find all the missing sides and all the missing angles. For number 33, there's just 2 triangles put together. So you need one to get to the other.
So you have to find both.
Yeah, it gave you it asked for all the missing angles on both triangles and then all the missing sides in both triangles. Brian?
I got TF and TF correct. I don't know.
For 33?
Right.
Okay, so you got the angles.
Right.
So this was 50. And then if this is 90, this is also 90, right? And then if if you look at the big triangle here, and this is 90 up here, and this is 40 over here, that means this angle is 50. That means this angle has to be 40. So that's how you can find all those angles, right? Then it says to find which one? Did you get wrong? DF?
DF and EF.
DF and EF. Okay, so DF comes off of the big triangle, right? So I would use this larger triangle. I know the angles and I know this side. I am 100% certain that 40 is right because they gave it to me, so I would stick with that angle. And then if I wanted to find, let's just call this X so we make it a little bit easier. 10 is adjacent to 40 degrees, and X is the hypotenuse of that big triangle. So adjacent and hypotenuse is what? Cosine. So the cosine of 40 would equal adjacent, which is 10, over the hypotenuse, which is what we don't know. And then I would do X equals 10 divided by the cosine of 40. And that's where that 13.1 comes into play. And then for EF, so let me erase this stuff. For EF, I can use the same triangle and the same information, 40 and 10, but let's call this Y. Now I would say that's opposite and adjacent. So this is tangent. Yeah, tan 40. Y over 10. And I'd get 10 times the tangent of 40, which is your 8.4. Any other questions from the review? Okay. This question came off of one of the quizzes, like the values might be different, but oh, and the top one was the right angle, right? This is. Okay, and it wanted you to find A, B, and H. So I like innately start with H just because that's the altitude. It's usually the easy one. So I would say that the segment 1, which is 4, over the altitude, which is H, equals altitude over segment 2. And then I would cross multiply x squared equals 4 times 32. And then I'm going to have to square root this, so I'm going to keep those separate, and I'm going to continue to break that down. So this would be 2 and 2, 2 and 16, 2 and 8, 2 and 4, 2 and 2. And then for each pair of 2's, so that's 1, that's a second one, that's a third one. All of those are going to go to the outside of the square root. There's only 1, 2 left underneath. So then 2 times 2 is 4, times 2 is 8, root 2, and that's your H. Then if I want to find A is a leg of that big triangle. So I'm going to use the hypotenuse over leg equals leg over segment of the hypotenuse adjacent to the leg. So hypotenuse is this whole thing, which would be 36. 36 over the leg, which is A, equals the leg, which is A, over the segment of the hypotenuse adjacent to the leg, which is 4. A squared equals 4 times 36. A would equal the square root of 4 times 36. Now those are both perfect squares. I know this is 2 and 2, and this is 6 and 6. I can continue to break that down even further, but at some point I'm going to bring it outside anyways. There's 2 2's, there's 2 6's, which means A is 12. If you had kept going, then this would be 2 and 3 and 2 and 3. This is 2 2's. This is another pair of 2's. And there's a pair of 3's. 2 times 2 is 4, times 3 is 12. So either way, you end up with the same answer. Then the last one that you're trying to find is B. Also a leg, but it's on the other side. So I use the same hypotenuse, 36, over the leg, which is B, equals the leg, which is B, over the segment of the hypotenuse adjacent to the leg, which is 32. So then I cross multiply. B squared equals 32 times 36. B equals the square root of 32 times 36. And then I break it down. So this is 2 and 16, 2 and 8, 2 and 4, 2 and 2. This is 6 and 6, so I can take out a 6, or I can make it 2 and 18, 2 and 9, 3 and 3. One pair of 2's, a second pair of 2's, a third pair of 2's, and a pair of 3's, and one sad little 2 by itself that stays underneath. This is 4, 8, 24 root 2. That was B. So keep in mind that your calculator might help you divide that down. Like if you have a huge number and you want to divide it by 2, divide it by 2, divide it by 2, you can use your calculator for it, but you cannot give me a rounded answer for this. That answer has to be kept exact, which is that 24 root 2. So there's a good chance you see something like that again. Questions on, any other questions on the quiz? Any other questions on the review?